Hello, now we are going to discuss about the overlap add method by using a problem. The question given is find the output y of n of a filter whose impulse response h of n that is given 111 and the input signal x of n is equal to this one using overlap add method. Okay, all of we know that the output of a system whose impulse response h of n, okay, output of a system is generally denoted by y of n whose impulse response h of n and the input y of n. The relationship between these input output and impulse response is shown in block schematic as this one. Okay, now let us start the overlap add method. Before proceeding, let me write what we have given. Okay, given y of h of n and x of n. Okay. Okay, next we have to divide the input data sequence x of n into some blocks of data such as x1 of n, x2 of n, etc. etc. Let me write h of n here 1 comma 1 comma 1. What is the length of h of n? Here the length of h of n is equal to 1, 2, 3. It's 3, let it be m. Okay, in order to make the data blocks x1 of n, we have to choose a data length, means the number of data to be chosen from the discrete signal x of n. Let it be L. L is equal to, L is equal to 3. Let it be. Take L is equal to 3. The number of data points to be picked from the given sequence x of n. Okay, right? Now let us construct the blocks x1 of n, x2 of n, so and so. First, let us construct x1 of n. x1 of n. Here the number of data points is equal to 3. So we have to take equal to 3. Three data points from the given signal x of n. They are 3, 1, minus 1, 0. Okay. Next, put m minus 1 zeros. M minus 1 in the sense the m is the length of the impulse response, that is equal to m, and now we have to put m minus 1 zeros. Minus 1 gives 3 minus 1 is equal to 2, so we have to put 2 zeros. These are data points. Okay, L data points, 3 data points. Okay, 3 data points, and these are m minus 1 zeros. Okay, right? That is the discrete data block x1 of n. Next, let us construct the data block x2 of n by choosing another L data points. Another L data points means L equal to what we chosen is 3. So we have to pick up or take next 3 data points from the given signal x of n. 1, 3, 2. Then again put m minus 1 zeros here. M minus 1 zeros means 3 minus 1 is equal to 2. 2 zeros. Okay. L points and m minus 1 zeros. Okay, right? Similarly, construct x3 of n by taking the next 3 data points. Okay, next 3 data points means 0, 1, 2, 0, 1, 2. Again Next again put two zeros, minus and zeros. Next we have one data element remaining here, so we have to construct one more block x4 of n, x4 of sorry x4 of n, that is equal to only one data element is available here. Actually the data element length is equal to 3, so in order to make the data number of data points equal to 3, you have to put two zeros here. L points, L equal to 3, so 3 points. Only one data element left here, so to make the length of the data points equal, you have to put two more zeros here. Next, as in the same manner, we have to put a minus 1 zeros here. Minus 1 zeros. Now it's over. Next, we have to convolute x1 of n with the impulse response, then convolute x2 of n with the h of n, and so and so. Okay, right. And the impulse response h of n given is equal to 1 comma 1 comma 1, and the length of the impulse response is equal to 3. But according to the discrete blocks we chosen, the length of the data points here is 5, 0, 3, 4, 5. The number of data elements, or the length of the data blocks x1 of n is equal to 5, x2 of n is equal to 5, length of x3 of n is equal to 5, and the length of x4 of n is equal to 5 itself. So in order to perform circular convolution with x1 of n and x1 of n with h of n, the length should be of same. Here the length is equal to 3, here the length is equal to 5. So you have to change the length of h of n. To perform circular convolution, the length of the sequence must be of same length. Okay, so what we have given is x of h of n is equal to 1 comma 1 comma 1, and the corresponding length is equal to 3. To make the length is equal to 5, we have to put two zeros. That's okay, right? Next, perform convolution between x of n and h of n and obtain y1 of n. Y1 of n is obtained by convoluting the first discrete block x1 of n by circular convoluting. Perform circular convolution between x1 of n and h of n. And I'm not showing the detailed steps of performing this circular convolution. I have mentioned in my previous videos. We can find the circular convolution between these two discrete signals either using concentric circle method or using matrix multiplication method, whatever it may be. You can choose depending upon your convenience. Anyway, the steps to find out the circular convolution is not going to explain here. For that purpose, just refer my previous videos. I will give you corresponding link in the description box. Okay, and here I'm going to write the final answer for y1 of n, that is equal to 322 minus 1 0. Next, find y2 of n by convoluting x1 of n and h of n. x2 of n. x2 of n is this one, and h of n is. And now perform circular convolution between x2 of n and h2 of n, h of n, to obtain y of n. Again, I'm not showing the detailed steps. Okay, right? The result will be 14652. Please refer my previous videos. Okay. Similarly, find y1 of n. Okay, find y1 of n. Y3 of n by convoluting x3 of n with h of n. x3 of n with h of n, and the result will be. And finally, obtain y4 of n by convoluting x4 of n and h of n. This is circular convolution, and the result will be 1, 1, 1, 0. Okay, next we have to write the result after convolution. Means we have to write y1 of n, y2 of n, y3 of n, and y4 of n together to construct y of n, which is the last step. Obtain y of n by overlap add method. Okay. For that purpose, I am going to write y1 of n, y2 of n, y3 of n, and y4 of n together. Okay, right. Here I have written y1 of n, that is 3, 2, 2, 1, minus 1, 0. Then write y2 of n from this point onwards. Okay, right. y2 of n is actually 1, 4. That should be the minus 1 should come under minus 1, and 4 should come under 0, means m minus 1. Two elements. The last two elements are to be added together. We are going to add the last m minus 1 elements. That's why I have written over here. Then write the result of y2 of n obtained, that is 1, 4, 6, 5, 2. Then write y3 of n, that is just available here. Y3 of n, that will be, of course, that should also be started from the m minus 1 element, that is from here. That is 0, 1, 3, 3, 2, and finally write y4 of n of also. Of course, that should be started from 3, the position of 3 onwards. That is 1, 1, 1, 1, 1, 1, and 0, 0. Okay. Now we are going to write y of n from these data. Okay. First, write the first 3 elements, 3, 2, then 2. Next, last m minus 1 element and the first m minus 1 element of the preceding block, that is going to, these data are to be added together. Minus 1 plus 1, minus 1 plus 1, then 0 plus 4, 0 plus 4. Now write the next elements from y2 of n, that is 6, this element only, because we have to add this 5 plus 0. 5 plus 0, then perform 2 plus 1, 2 plus 1, then write 3, next add 3 and 1, 3 plus 1, next add 2 plus 1, 2 plus 1, then the remaining 1, and here we have 2 zeros also, don't need to be written here. What we have done is this m minus 1, the last m minus 1 element of y1 of n and the first m minus 1 elements of the next block, I mean y2 of n. we have to add those two elements together. Okay, right. And write the other elements 3 comma 2 comma 2 here. Next write and next add -1 with 1, that is added here. Next 0 plus 4 again, don't need to nothing to add with 6, so I have just written 6 here. Next 5 plus 0, again 2 plus 1, then 3. Now add 3 plus 1, means these elements are to be added. Okay, right. Next this one and this one. 3 plus 1, 2 plus 1, then 1. Okay. Now let us write the final result. 3 comma 2 comma -1 plus 1 becomes 0. 0 plus 4, 4, 6, 5, 2 plus 3, 2 plus 1, 3, 3, 3 plus 1, 4, and 3, 2 plus 1, 3, and that is the output or response of the system using overlap add method. We are adding the last m minus n elements with the first m minus 1 elements of the preceding blocks. Hence the name overlap add method. Okay, bye, thank you.